Okay, continuing with lesson 6 of the Geo-Python course. I hope you can see my screen well. What I did now during the break is that I restarted my kernel and run the cells up until here. I think now the data looks fine, but in case there was something weird, we can always then update it to the web pages. So let's continue with a focused mind. To wrap up, we went through these different ways of applying functions, modifying data in Pandas data frames. There are different things. Some are more efficient, some are not. But between these approaches we now showed, we did recommend using these one-liners, apply or something else whenever possible. But of course, especially if working with smaller data sets, as long as your process works, it doesn't have to be the most fast and elegant choice. Let's move on with one of the main topics, or preparing for one of the main topics of the latter part of the lesson. So as you remember, we are now interested in seeing these warm April temperatures from 2019 in this weather data across weather stations in Finland. And our input data has precise measurements from these stations. The date or time information in this year moda Herman column that we renamed. So the information in there is year, month, day, hour, minute. So each row represents a minute or something more, something less precise, but the information is to the minute. But we want to know for each row the month in order for us to analyze temperatures on a monthly level. So let's check a bit what we have. We have this time column. In there, if you did the renaming, these are the first lines. I'll just go ahead and copy this here to see the last lines. So our first observations are from 1906, so over 100 years ago, and then the latest observations are from 1 year ago. So it's quite a long data series we have in here, and with this data we can, for example, answer the question that what was the warmest April during last century. All right, so let's check a bit more closely. We could check the data type. I'll copy again this data and reference to the time column .d types. So this is now an integer number, as Pandas has read it in from our text file. And well, we can work with this further, but to start with, we will now convert this row of numbers into a character string, because then if we have a character string, we can start slicing and cutting pieces out of there. For example, extracting information about the year, the month, the day, the hour, and so on separately. So we are indeed interested in the information about the month and also about the combination of the year and month in order to analyze separately the months during this data series. We did go through data conversions, was it last week in Pandas, but let's now refresh our memory. So we want to have a column called time. We can call it time str to remember that that is the one that has the character strings in there. Chat. And to there, we want to have values from the time column converted as from integer to string. So there's this column.asType function, and then we pass the type that we want. For the output, I'm creating a new column in here, data dtypes. So now you can see that we have this new time str column and its object. So character strings show up as objects in this data type summary. So we can continue working with that information now. So again, there are many things to access information about time from this type of data. But the very kind of simple and practical approach that is now enough for our purposes in this analysis workflow is that we can just take the string of characters and then slice or cut a substring, so a piece of the bigger string that represents the information that we need. So we could, in order to know how it works, so let's take one of these character string time informations and store it into a variable. So I make a new variable date, and then I just copied this piece of, or this time information as a character string, and let's store it in there. And how we can then do string slicing, so cut smaller parts from the string, is that we can treat it as a list of items, or a list of characters, which then also have an index. So we have index 0, 1, 2, 3, 4, 5, and so on. And similarly as with, well, lists, or then last week when we learned to slice Pandas data frames, we can specify that what range of this list of characters we want to keep. Sorry, syntax error. So we take the variable that stores the string object and then specify starting from 0, going up to 6, and 6 is not included, so 0, 1, 2, 3, 0, 1, 2, 3, let's see what this gives us. So 0, 1, 2, 3, 4, 5. So the 5 first characters represent the year and the month, and that information we would want to have on each row in order then to aggregate, to analyze each month separately later on. Okay, so this is how you would do it if you just have a character string separately in Python. But then for the Pandas data frame, it's the same process, but the syntax is a bit different. So again, I think what kind of output I want. So I want a new column with information about the month with the year attached. So year, month column. In there, we will then want information from the time str column. Here, I think you need to put this str, so we kind of use these string methods in a Pandas series, and then from there we use the slice method. So it's the same approach as here, but it has a specific method available in Pandas, and there we specify the start index and then stop index. And you can see more information about this function in Pandas documentation. So it's this series.str.slice method. Okay, I hope you followed. So output column, input column, and then the method. And now if we print the head of the data, you see this new column. From this character string column, we have then taken a substring, so the 5 first characters in here. So now, as you can see, there are several observations from, from one month. There might be then for latter years also several observations from 1 year. So all of those get a common label that we can then later use for grouping. All right, so time to check your understanding. Using this approach in here, please create a new column month with information about the month without the year. So for example, 01 for January and so on. So using these indices, you should locate which part of the character string has the wanted information and then store that as an output. There, maybe I'll leave it like this so you see the previous syntax in there. So let's spend a couple of minutes on this before we proceed. So we make sure you understood this string slicing. Okay, there they came. So we want information of the month. So 2 numbers which are located in this character string 0, 1, 2, 3, 4, 5. So 4 and 5 are the locations. So we need to start at 4 and stop at 6, which won't be included in order to get this information. Let's see how it looks like. Just printing out the column. So that looks correct. If I do unique, I should have these 12. January, February, March, and so on. So now this data month column only has these 12 unique values. I'll just actually check how much data we have. So we have quite a few rows. We have, is it now 700,000 and something rows of data, but this month column only has 12 values. All right, we're ready to proceed. Just as a wrap up of this string slicing, it's not a universal approach now for dealing with dates and times, but it works for our case as we have this type of date format. We will skip the next part for the lesson in the interest of time, but it's good that you know that Pandas and Python has then specific data type for dates and times. So we can then also, this is for some reason a bit slow, but it will go through. So it is also possible to convert often starting from a character string representation of the time to convert that into a date time object, which is then a bit more clever as a data structure. And especially useful, for example, if we want to plot a time series and you want to format the x-axis nicely with the time label. So if you want to do calculations on the time information, so date ranges or something like this. So then you might want to have your data in this date time format, but it's a bit more tricky to grasp. So we won't now spend time on it because you won't need it in this week's exercise, but just as a note for later. So there is this specified or dedicated format for dates and times. And then you can, for example, if we have data in a column in this date time format, you can access years and months and hours and minutes using these specific things. So you can read that part more closely from the web pages. But now we go maybe to the most important topic of today, which is aggregating data in Pandas by grouping. So those of who you did optional exercise 4 last week might have already managed to do this or a similar thing with last week's data. But we will now go through the whole thing because it's it can be conceptually a bit tricky to understand what's going, and then also to know what all you can do with this group by method in Pandas. So let's see the main tool that we will be using while the page downloads. So grouping or aggregating data is basically a process of, well, first we will split the data into smaller chunks, for example, based on the month. So we take all the rows which have the identical month, And then we do operations on those subsets and finally summarize the information. Today we are dealing with this, we are aggregating over time. Another example could be if you have, for example, geographic data on postal code level. So you would have one row of data for each postal code, but then you have another column which tells the municipality or the county. So then we could group by based on county and take, for example, averages or other statistics from all the postal code areas that belong to a greater entity. So that's the idea there, to make bigger data smaller and get some information out from there. And when we use this group by, we have some data frame, and then we need to specify by which column, by which attribute we group, and then there's some other parameters we can use, but this by parameter is the most important one. What else? So indeed here the goal is to group the data based on this year-month combination and then calculate the average temperature for each month in order for us to then detect which months over this long time period were the smallest or coldest or whatever else. All right, so I hope you're ready and focused. Let's go. So I actually already did this, but we have this 750,000, or is it even more? I'm really slow this morning, but many rows of data in our data set, and we want to compress that into a smaller data set with information of each month from each year. And just to remind of the data structure, we have now created some new columns. We won't need all of these, but we'll be then operating on, these temperature columns in there. Let's hope that our temperature conversion was correct. But telling from these values, it's at least in the right magnitude. All right. So then we will group the data based on the new column that we just created. Just a second. Let's create an output. So we will have this grouped object, or we will have a variable with the data in this kind of grouped abstract thing. I'll explain it in a bit. And we have our data, and we call group by. Then there was this by argument, and we have the labels for our groups of data in this year-month column. So year-month column, you can run that. It shouldn't be too slow. There's a note in here that if in case we would have data in two separate columns, that we would have a year column and a month column, we could also pass a list of columns, and then Pandas would deal with checking the kind of unique combinations of those for each row. But then we will get a bit more complicated index in our, or key in our further analysis. So it's now easier to have this pre-processing step of having this label in place. Okay. So I hope you are now here with me. We have this grouped object. So let's explore it a bit. We now have a new data type, which is this data frame group by. It's not really useful as such before we actually get some information out of it. But then what is the length of this grouped? So that's 601. You remember that we had so many rows, thousands of rows, but then this grouped object has now 600 groups. And what is that? So that is the number of unique values, or should be the number of unique values in this year-month column. So we have now, as I mentioned, grouping means that we conceptually split the data into chunks or these groups, and we want to continue analyzing these groups separately. So now we have these 600 groups, one for each month per year. All right, moving on. You could, there's a different number, I think, for the smaller data set. I don't recommend running this this code, but if you would want to know, like let's say if you only have 10 groups and you need to know the kind of group names or keys, then you could run this command groups keys, but now we would get 600 keys printed out on the screen, so let's not run it, but that's the syntax. Basically, it would print out these unique values of that column on the screen. Okay, so let's start accessing this grouped object by looking at one individual group in there, so that we then understand what happens later. And for that, let's pick a month or year month to be more precise. So I create kind of this helper variable, and let's define a character string. For example, the first month that might be in the data. Actually, I hope that this exists there. Then change if it wasn't there. So January 1906. That would go into this as our month, and then let's get one group out of this grouped object, and that we can do by accessing it using this get group function of the group object, and then by passing the key. So this is now one of these 600 unique values that are our group keys. Okay, so let's see what we have. If I just type in this group 1 and print it out, so you see that it's a Pandas data frame. Looks familiar, right? And at least on these on all of these rows, I'll scroll back up soon. So we have now a Pandas data frame. So we have kind of taken all those rows that have this specific year-month combination in this column. You might remember from last week that we could do this also with a selection, right? But as we want to do all the unique groups, then this grouping approach is the way to go. All right. In case I'm going too fast or you didn't grasp something I explained, please ask in the chat. I have it open here in the other monitor. But so far we have grouped our data based on year month. We have accessed one group, and we have learned that one group is a Pandas data frame. We can make sure that it is one by checking the type. So Pandas data frame. And with this information, we could then apply whatever Pandas functions or data processing steps, or write it into a file. If you would want to split your data into 600 files per month, we could then now do that, for example. Still continuing with this one group out of many. Let's see how we can then take out some statistics for selected columns. So we have predefined this list of columns that have some meaningful observations, numerical values, and I'll create a variable for the output. And then if I take, so I here just select these columns that go into this variable. So I pass the list of columns to this Pandas data frame that is one of these 600 groups. And then I take the mean value. So let's see what that would give us. So I bet this is now a Pandas series with then mean values for each of these columns for that specific group. So this is just to demonstrate that if once we are dealing with one of these groups, it's a Pandas data frame, we can subset it, take statistics, apply functions, and then continue with that output. Okay. So now we did it for one group, but we have 600 groups. So how can we take statistics for each month separately but efficiently? So again, there are different ways, but I'll show first how to do this with a for loop. So as we previously saw, this for loop with these iter rows, The syntax is a bit similar when dealing with these grouped objects, but I think you will mostly, this one you will actually need to use, for example, in the exercise, and it might be useful also overall when processing data using the grouped function. There is also a shortcut which I'll show briefly. So we have some code here ready. So we will want to do something for each group, and for each group we will print the key and we will print the first lines of the data. Just to learn the syntax. And here we have again this break function. So this for loop will only process the first iteration and then it will stop. So it won't print out information of 600, it will print out information of 1. How to write the for loop? So for, let's do this something in grouped, and then for what in grouped. So this is a bit same as in the iter rows. So how the grouped object kind of groups the data is that there is information of the key and then the actual group. So this grouped object, in essence, it contains these key group pairs. And if we do something for each group, we can access the key and then the group by having these two variables in the for loop. Let's see what it does, so it's maybe easier then to re-explain. So the for loop starts from here. It takes from the grouped object the key and the first group. Then it prints the key. So our first key is this January 1906. And then it prints, as we have the group, first group now in this variable, it prints the head. So this is the 5 first rows of this January 06 group, right? Okay, if you want, you can try and take out this break and run it. I won't do it now in the interest of screen space, but then you would get information printed out for each group. And then you can imagine you can here then do whatever statistical calculations or other processing steps for the separate groups. Okay, please, if you have any questions of this for loop or then these keys and groups, I'm happy to answer. Okay, so somebody is asking, could you please quickly go back to the part where you created new string columns for time? Just as a side note, you can go to the web pages of this week and also check it from there if you missed something. So where was it? So basically this part in here, year, month, from the character string column slice, these ones, and was it even the spot where we create this one? Somebody is asking, so that happened then earlier. It was here. So from the integer numbers, we did this conversion to string. But indeed, you have all the filled-in solutions on the web pages if there's one specific syntax you missed during the lesson. Okay, I hope that helped. Tuuli is asking, is it possible to break the loop after a specified amount of loops? For example, break after 5. I'm sure it is, but if Dave is listening, he might know the answer by heart. I don't remember, but I would assume that it is.
Yeah, I guess I don't know for sure. I mean, the way that I would approach it in terms of my normal programming approach would be just to make a variable that's equal to 0 at the beginning and then just iterate each time, and then have a test in there that says if your count is greater than 5 or something, then to break. I don't know whether break is something itself that keeps track of how many times the loop has iterated. But essentially, like what Volko is writing right now, it's you just have something where you set the variable that's a counter initially to 0. Then each time you pass through the for loop, you add 1 to the variable that you've initialized, and then you can have a test that says after so many times, then break.
Yeah, thanks. That's indeed probably how I would have done it, and it's a good question. Thanks, Tuuli, and good way of really, if you're developing your code, which might then even be a bit slow, so test it with some example values, but then also remember to take it out before, for example, producing final results. So, but for different reasons, you might want to do something like this, or then to count the iterations. Okay, other questions? We can share this syntax on Slack for later, as it's not in the lesson materials for having this counter and self-defined break. But let's continue now after all these 5 printouts. So as you can see now it printed for the 6 first days, it printed this data. Yes. So what do we have then next? So next we can then actually do some meaningful, other than printing out the data, we can start taking out some statistics from there. So we have here the comments ready and some code ready, but let's think this through from the scratch. And again, especially with when grouping data, it's good to think of the data structure of the output. So what do we want? We want a data frame with monthly data. So on each row, there would be a record for this year-month combination, and then the average temperature, and we could of course add other statistics as well. And here we will just do an empty data frame from scratch. There are some materials for explaining this, constructing data frame from scratch without any output in last week's materials. But for this purpose, we can basically just do like this, that we call this constructor pd.dataframe. If you want to be more in control of the structure, you could here define the index, column names, and so on. But our example will also work if we just have this empty data frame where we will then add things as we go through the groups. Okay. We will work with these same columns as they have some meaningful data. And then again, for each key group pair, we will want to calculate the mean values. And as we saw before, for one group, so again, this happens for one group at a time, so we will just put that process inside our for loop. So at this point, we should then have in this grouped object, from the first group, the mean of those columns stored in here, which would be a Pandas series. And then we want to put this information into the new data frame that has a different structure. And we want to, first of all, store the information about the month we are processing. So for that, we put, let's do it like this. There's different ways of doing it, but we can also add, now that we have a data frame in here, so we can add one value to that data frame, which then would represent the year and month. Maybe later show another approach to this. So what happens in here is that we have now a Pandas series with our mean values, and then we add one value with the label year month there and store the current key. So we keep track of the key that we are processing, and then we can append the result to our data frame. And I'm not sure if we already discussed data frame append. There's now many new things coming, but basically it takes, we have now in a way a row of data. So this series, and then when we append a Pandas, a series to a Pandas data frame, then it adds a new row of data. Let's see, then we still have this ignore index equals true, but I'm tempted to see what happens if we don't have it. Let's first run this without. Oops, now I have indentation error. So here you see that we are again, for some reason there's only 3, maybe I'll do like this. Fix my indentations. So you can work with either 3 or 4 spaces, but 4 is the recommended one. There we go. Then what else can I only append a series? Okay, yes, so we actually need this ignore index equals true. Just delete the error message and have it in here. It didn't take too much time. So what happened is now that Pandas came in here, it created the empty data frame, created a list of columns, started to iterate the groups in this grouped object. So on the first iteration, it takes the first group. From the first group, it takes selected columns, mean, takes the series out of them, adds in the key to that series, and then appends the values in there to the output. Let's check what we have. I'll take out the print statement so we get this nicer layout. So we have indeed now, I'll scroll up in a bit, but I'll just show what we get as output. So we have data frame monthly data that runs up to index 600. So we have 601 rows, exactly the same number as unique year-month combinations. And then we have the mean values for each of those as we appended the rows in there. I can provide a bit more material on this monthly data append. So there are different ways in which you can then, if let's say we would have an existing data frame with column names, you could of course then use this and you would be calculating only one value in here. You could then, using this lock or at, also add the value into the desired location. All right, any questions at this point? The most important thing is that you understand the grouped object and that in the for loop, we process one group at a time, which is kind of a subset, a mini Pandas series inside the bigger series. We take statistics, we do calculations based on the subset, and then store those outputs somewhere. That's the main process. Okay, and that was the output. Okay, now after introducing this long and complicated for loop and way of putting then the data inside a predefined data frame, there are shortcuts which work for simple things like taking the mean. So we have the grouped object, and if we, for that, type in the mean, you actually get a similar output. Of course, here now we have all those also these columns that we wanted to exclude, but we can of course then exclude those later on. So for some simple purposes, the grouped object has these methods, and I think you can, now I'm improvising, but do something like this. So the grouped object has, in a way, as a variable, the variables or the columns that we have in there, so it can access on the fly from each group a specific column and then take the mean. So this might also be useful in some cases. But we teach this for loop because sometimes you need to do more complicated things. For example, in the AutoGIS processes course, we will do we will create some trajectories for subsets of a bigger data frame, so that you can't do in a one-liner like this. Okay, so in this week's exercise, I think there are options. It's a good thing if you do things with the for loop, because that shows you have understood the structure. If you can find out some shorter ways of arriving to the same solution, that's totally fine as well. And as you can see, still to repeat, so this is also the length of 600, which was the number of unique month-year combinations in the data. Okay, that was the main points related to grouping data, and that's the main thing we hope that you learn that based on this course. But let's continue a bit as we have some time. We might go a bit over time today, but not tragically. So let's finally solve our actual question related to detecting warm months and seeing if the statistics support the fact that April 2019 was the warmest on record so far. So how to approach this problem? For sure, there are many different ways, but one simple thing is to, as we're focusing on Aprils, so let's extract Aprils from the data. How to do that? We can use the tricks we learned last week. So let's take a subset of the data based on a condition, and our condition is this month column that you hopefully have in there. It was part of one of these test your understandings. I'll quickly create a new column to check. So we have data.head. I don't remember by heart. So we have this month column. You should have these 2 character combinations of months as character string. So 04, oops, not 04. 04 would stand for April, right? So again, I have this here. Oops, this is the, sorry. Inside the brackets, I have a condition. So Pandas goes and checks all the rows where this condition is true, and then takes out those rows in our original data. Okay, and stores those into a new variable. I hope my internet is not failing. Else. Something funny is going on. Yeah, this might sometimes happen that you get these raw cells, so then you just put it back to code cell and it should run. I hope you had time to type this in. So condition inside brackets will give us a data frame with those rows that are from any given April during this over 100 years time series. And furthermore, there you should have this code ready. Let's select just some of the columns so that we can then better see what we are dealing with. So we have now selected data from Aprils from our original data set, and then these selected columns. And we will now, focusing only on these Aprils, based on our study question, we will group the data. So again, we can overwrite grouped, the original grouped object. We'll take this April's data set, dot group by, and then by, again, we want to then group by year, month. Of course, now we only have April, 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 April. So basically you are grouping by year, but the same information is in here, like we did before. So we have subset of data, we have grouped it. and we can proceed. I think we have no more check your understandings in here in the last part of the lesson, but of course now if you're faster than me, you can already try to calculate mean values for the variables that we have. And we can actually, in this case, use this quick approach. We get the mean Fahrenheit temperature, mean Celsius temperature, and then the station number, which is the same for all the rows, as we're still dealing with this Tampere-Pirkkala data. And actually, we can continue working with this monthly mean. Let's just store it into monthly mean variable. Again, print out what are we having as our data frame at this point. Okay, so as you can see, when we grouped by this year, month information, we now have for one row 1906, 1907, 1908, April. So all the Aprils up until April 2019. As this data didn't now contain April 2020. So it stops in last year. Okay, and I think it should be logical that our data frame length is 601. Or maybe this. Sorry, not 601. It's then divided by 12. Anyway, moving on. We can, of course, then actually already with this information, we are quite far to solving our great problem. So was indeed April 2019 the warmest one? So there could be, of course, more fancy ways of doing that, but a very quick way to visually confirm the thing is to sort the values. So sort values, data frame dot sort values by temp C. Let's check the Celsius temperatures. I'll run that. Now we get the coldest one first. So it has been rather cold, somewhere in the 80s, and the warmest one would be down here. So indeed, it is 2019. Just as a refresher, if you want to sort the data so that the highest value is above, so ascending equals to false. There we go. So this already proves our point that 2019 April was the warmest on record, and already like during the 2000s it beats the other Aprils by quite a margin. So we could say that we have already managed to solve the problem for at least in Tampere-Pirkkala, which was this station number 29440. All right. So in here, indeed, as we're only taking the mean value, we can skip going through the grouped object with the for loop, but I hope you remember that syntax also for then the later weeks, and especially for the second teaching period. Okay, there's still kind of the grande finale of this lesson coming up. And I warn already now that we will go a bit over time, but we have now gone through most of the techniques that are relevant. So next up, we have some readily filled in data cells. So that was supposed to go down there, but I already had this. I'll just grab that from there. To have it here in the right place. So indeed, April ranks top 1. But then, as you remember, when we started this lesson, we did download a bunch of data. You should find them from this notebook's lesson 6 data folder. So 1, 2, 3, 4, 5, 6, well, many files, which then represent these different stations that we have information about in here. So we can then, of course, see that was April the warmest on record, April 19 warmest on record throughout Finland in all these stations we have data from. And how should we do this? Of course, we could read in data, Pandas, PD, read CSV separately for each of these, but you might start to think that, hey, we're doing something for each file, so we can probably use a for loop to repeat these steps that we have already now developed and tested with Tampere Pirkkala. So it's a good approach, take one set of data, develop the approach, and then repeat with a larger number of input data files in this case. Okay, going back to the notebook. So what we have here ready for you now is all the steps that we have gone through now, starting from reading in the file, renaming the columns, printing some info. This is actually an addition. Then applying the function, detecting the month and the year, and then extracting April's, and then finally extracting the statistics. So we have all those steps now all in one code cell. So until now we have been kind of learning things with little code snippets, code blocks, running these cells kind of in little pieces and then checking the output. But now that we have developed and tested this process, we can actually do it, of course, more efficiently if we had it in one code cell, or better yet than in one Python script file that we would just run all at once. I now ran this, it went through quite quickly, and we get, as an output of this, we get like a nice printout. What we see on the screen comes from here, so we print the station number, and we get, using the @accessor, the station number from this data file that we are processing, as it's the same for all the rows, so we can just print out one. We print the number of observations, so the length of the data, and then we do all the processing, and then finally we print, as after we have taken April's, sorted the data, so we print the top 5 records so that we see if April 2019 for that station was the warmest. Okay. So this code cell it's a bit long, but now that we have gone through all these steps one by one, I hope you understand what's going on in there. And as you see, there are then, well, I think it's quite nicely formatted. We have always a bit of like one empty row before a new process, some motivating code comments, informative variable names, and then finally the output. So here we, well, repeat the process again for this one station. But then how could we take all these files and for each file repeat the thing? So for that, of course, then we need access all the file names, because our process starts with this read CSV FP. So basically this FP will be the only thing that changes in our code. Everything else is standard format, but this file path is different for each code. So somehow we should access the file paths and then put that in so that we loop over the file paths and pass the new file paths to the code one by one. And for this, we have a nice tool or package called glob that we can import. And glob has a method called glob that we can then use for listing files in a directory. Maybe glob can do many things. Wait, glob. Let's see if I quickly find the path name pattern expansion. Was this now the correct documentation? But in essence, we can use glob to pass some path to a directory and then a pattern to find file names with a specific structure. So for example, in here, they're finding all files with the extension GIF. You can go and read this more carefully. What is our pattern? So we want to get from our file structure, from this specific folder data, all files that have extension text. There's another problem that we also have these metadata files in here, which we don't want to read as weather station data. So we need some other pattern. So it's not only whatever.txt, but is there something else? So all these data files start with a 0. So we can have that as a pattern. So we want to use all the files in this folder that start with a 0 and end with .txt, but then whatever is in the middle can vary. So using that, we can take glob.glob, so from the glob module, the method glob, and then we need this pattern. How we will do it in here now, I'll put the R in front, so we will basically pass a file path to the directory or all these files. So as we are working from our working directory is lesson 6, so we can start building our relative file path there. We have data folder dash 0, then whatever. So this wildcard dot txt, and then end of character string. Okay. Let's see what that gives us. So I hope you're following what happens. Glob goes to data folder and starts to list everything in that path which match this pattern. So it looks for all files that start with 0 and then ends with txt and gives us a list. Okay. So we have a list, and we can store that into a variable like this. Glob is very useful, very powerful, and it can be combined with other utility functions such as OS path, which I hope we can demonstrate still next week. But for now, this is enough for us. Then, okay, so we have a list of the files. We have the process, right? And we identified that we only need, in the process, we only need to change the file path in order to do this thing for all the input files, which have the same structure, only the different station number and different observations, of course. And we know how to make for loops, right, already since week 3. There's some print functions for us to help us understand what's going. So I'm just printing information of this file list, and number of files is 15. So thank you, Python, you helped me count how many files we have. And just a refresher, how can we do a for loop that goes through items in this list? We can do for fp in file list print fp. So now for each round of the for loop, we have one of these file paths in processing. And then in all simplicity, we basically take the process that we have. So read in file, extract April, group the data, take mean, print out the ranking of Aprils, and would put it in here. And we have that readily made in the next cell. So we have this file path in file list. Then the file path goes in here. On the first round, it's maybe Tampere-Pirkkala. On the next round, it's Kumpula. Then it's Sodankylä. So for each 15 times, Python will go through this loop and then read in the data, rename columns, print info, so on and so forth until we get the ranking. Maybe some of you already ran that. So it starts going probably in alphabetical order or something numerical order. So we have station number 29170. Actually there, February 2019 is only the second warmest. So that's it, all same in there. So we could check what are these locations. Maybe they are in the north. But then 2014 ranks top here, not that much. There, yes. There it's not even in the top 5. Here, yes. So on and so forth. So based on this, we could say that 2019 was at least among the top 5 warmest, and often the top warmest, but not in all the observation stations that we have in this data set. Okay. So I hope this gets you an idea that we have developed the process for some input file, and then we repeat the process for several input files. And then, of course, we could do additional things. We could write output files for these subsets of the data and so on. So this is now basically the first time we're actually automating a data analysis process for already quite a large set of data. And in between there, you learned how to group by data, apply functions, slice strings, and everything else. So I'm sure that you have now hopefully learned a lot and ready to go get some lunch. I don't know if Dave would want to, do you, Dave, want to introduce the exercise and maybe say something else about, maybe before I pass over to you, one word about the exercise, that there might be some techniques that we haven't now introduced, but that's also kind of one of the points. So the point is that if there is some process, so for example, you will have to do a table join, which we haven't yet taught you. So please ask if that's difficult, but you should also be at this point able to read Pandas documentation and apply that information. So do that first. And if it's too difficult, then come to the exercise sessions, ask us on Slack. So the internet is full of information, but then of course always nice if somebody shows how things are done. All right, but yeah, I'll pass over to Dave and get some water.
And yeah, if you want to stop your screen share. Yeah. Okay. Let's see here. Maybe I can start sharing my screen. I know since we're over our normal finishing time, I'm not going to go through things in too much detail. I did want to point out a couple other things about the lesson that we didn't have a chance to get into, but you can perhaps read through. There's a section here about dealing with errors that basically walks you through how to interpret error messages. So it shows you some examples of the kinds of error messages that might come up for various mistakes you could make. For instance, syntax errors where you're missing a quotation mark at the end of a string, and how to try to pick apart what the Python tells you about the different error messages. These are messages that are intended to tell users what is wrong. So although they might look scary and sort of weird in terms of the syntax, if you do start to look at things piece by piece, you will understand some of what the message is telling you, and that can help you in fixing the problems. There's also a good coding practice for this week about using assertions. Again, this is something you can just maybe read through if you're interested, but it is one of these practices associated with what's called defensive programming. So that's designing your programs in such a way that if there's something that's not supposed to happen, the program will inform you by some way. And assertions are one method you can use. For instance, if you were to create a function for converting wind speed from kilometers per hour to meters per second, the wind speed conversion should probably be designed in such a way that if you give a negative number for the speed, it will give you an error message saying that the wind speed should be 0 or a positive number, since speed is a magnitude and a negative magnitude doesn't make sense. Finally, there's a couple tips about debugging your Python code, and these are just some kind of handy things to think about as we start to work with bigger data files. Sometimes you're going to have issues that are somewhat complicated to track down, and so there's some tips here about how to quickly resolve some common problems you might experience in your code by either working with known outputs, so working with a piece of a code where you know what the values are that you're calculating and what they should be, making your code crash quickly. So that means, again, if you have a problem in the code, don't let it process data for 20 minutes and then crash, but try to find a way to make it crash quickly and see if you can figure out from the quick crash what the problem could be. And then there's another example here about making small changes and tracking them. This is basically just being a good Git user and keeping track of changes on GitHub. So just, again, something to read through if you're interested. For the exercise for today, I think I have it open here already. This is on to exercise number 6 now. There's 3 problems that are the main part of the exercise, and then there's a 4th problem that is an optional thing. For the 3 main problems, the first thing you have to do here is we're going to be calculating some weather anomaly data. So this means that we're going to calculate what the average temperature is over some time period, and then calculate how far temperatures deviate from that average over time. And so the first thing we're going to do is we're going to read in the data files, or the data file that we're working with. So you're given a data file in this case, and you'll see that there are some things you need to handle in terms of reading that data file in. It's a little bit different format than we've dealt with before. For instance, containing -9999 values for the no data that need to be converted to not a number. And I will mention already that you're going to probably want to take a look at the hints for this exercise for some help with doing this data reading step. Once you've read the data file in, you'll then go through here getting some kind of basic information about what's in the data file, what's the first data, the first observation, what's the data of the last observation, what's the average temperature, and things like that. At that stage, what we're going to do is a bit of data aggregation to calculate monthly average temperatures. And so what we're going to do in this case is calculate temperatures in degrees Celsius that are the average for each month in the data set. So that should be for each month of each year. So if the data started in 1950, you would have January of 1950 would have its average, February of 1950, March, and so on. I say that specifically because we're going to do something else with that monthly averaging in just the next part of the problem. Anyway, what you should do here is you're going to aggregate your data to get these monthly average temperatures, somewhat similar to what we've done in the lesson, and convert things from Fahrenheit to Celsius, which also should be somewhat familiar. The third problem here relates to calculating these temperature anomalies. And so in order to do this, we first have to calculate what the reference temperatures would be. And we're going to do that in this case as the temperature from 1950 up to and including 1980. And what you should do is you would calculate, for instance, for the month of January over that range of years, what was the average temperature in January? And then you do the same thing for February, March, April, and so on. These reference temperatures can then be used to determine, okay, if we know the average over this time period from 1952 to 1980, for each year, we can then calculate how different was the average temperature in January from the reference temperature. And that way we could see things, for instance, compared to the average, are temperatures getting warmer as we get closer to the present day, cooling down, or whatever. We can see some trends in how temperature is changing based on the difference from the reference temperatures. So in this case, You can see, for instance, here, for the 3 first months, what the reference temperatures are that you should calculate. So when you test your code out and you calculate what your reference temperatures are, you can see the first 3 values here to know whether or not you're on the right track. Once you've calculated what those reference temperatures are, you then go through and you do a sort of differencing step where you calculate the difference between the reference temperature and the temperature on average for a month in a given year. In the end, what you should come out with is basically some temperature anomalies so that you can see for every month of every year how the temperature deviates from the average in the reference period. Finally, there's problem 4. In this first problem, we're dealing with data from the Helsinki area, and in problem 4, if you would like, you're welcome to go through and do the same set of steps for data from Sodankylä. And here you can basically go and download your own data and do the whole process of downloading the files all the way through to calculating the temperature anomaly data for another station. That is the exercise very briefly, and I will say at this point that this is one of the more challenging exercises. So again, it would be a good thing to get started on it somewhat early, and also consider whether or not you want to take some time to join in for the exercise sessions on Thursday and Friday, as you may find them more useful this week than perhaps in the previous weeks. I think that's sort of it as far as I'm concerned with the exercise. And if there aren't any questions, next week we're going to be continuing on with a little bit of data visualization. So now we know how to read in our files and analyze the data. And the next step is going to be to visualize the data. And I hope that will be an interesting experience to learn a bit about plotting and interacting with data in plots using Python. Any other questions or anything else at this time? I can't see chat, but it doesn't look like anything happening there.
Yeah, no questions at this point.
Okay.
Yeah, but yeah, please be active in Slack and good luck with the exercise. We know that the teaching period 1 is approaching its end and everybody has many things to do. So indeed, as Dave said, good to start early, at least checking how challenging this problem then is.
And thanks for sticking with us to the bitter end here. All right, thanks, and we'll see you guys next week.
Okay. Bye-bye.
Bye.